In the last exercise of this part of the series, Module 1, we'll be doing final CNC modifications inside of 3ds Max. These modifications will give us a better model, and they'll also make sure that we have the right scale established. So we'll be learning how first to transfer Revit topography into 3ds Max, modify the scale of the virtual topography in 3ds Max, manipulate the topography for the physical model, and export an STL or stereolithography file for the CNC router. So back inside Revit, just really quickly for one more piece, we need to do our final export as an FBX or film box file format. And this is the easiest file format that I've found to open up this model type inside of 3ds Max. So we'll save out the file as an FBX. And then we'll switch over to 3ds Max, where we will import the FBX format file. We're going to go ahead and accept the defaults. And the first thing that we can do is go ahead and delete the light and the camera. We won't be manipulating either one of those at all. We're not doing any renderings with this. We're simply going to export the data for the CNC router. So one of the first things that I always like to do is verify my scale. So looking at the top view, I'm going to use the measure tool inside of 3ds Max. And going outside edge to outside edge, we can verify that right now we're still working at 1:1. This is a 2,000 foot length across the overall size of the model. That is definitely not going to fit inside the parameters of the CNC router. So we need to scale this down. So I've built an Excel spreadsheet to help do this. So I simply input our scale factor, 60, and the equations that I've built simply give me the percentage output, or the percentage that I need to drop the scale factor to get to a 1 inch equals 60 foot model. So to do that, I'm going to select everything in this model. I'm going to select the scale tool and then the absolute transform at the bottom. And this is where I can input that value from my Excel spreadsheet. Now, as soon as I hit enter, the model seems to almost completely vanish, and that's simply because it's dropped from 1:1 now to 1 inch equals 60 feet. So use Zoom Extends All to zoom the model back in. And now we're going to remeasure to see if it's matching what we had in Revit on our CNC layout sheet. And it does. We're right at the correct dimension that we were seeing inside of Revit. So the next thing that I need to do is some basic modifications to this file so that a few things show up when we cut them on the CNC router. Right now, just because the road's a different color does not mean that it's going to show up on my final model. I actually need to raise that up. So how I'm going to do that, again, these are the parts of the model that we used the subregion tool on. And I'm simply going to raise that up by 1/16 of an inch. It doesn't seem like a lot, but when we're working at this new scale, 1 inch equals 60 feet, that's going to be a very noticeable bump in the model. I'm going to do the same thing with the tree line, 1/16 of an inch. And keep in mind, this is something that you can do with just about any site feature that you need to make sure is going to show up on your final model. Finally, we're going to go to Export. And from our export options, select stereolithography. Select the file name and save. Notice, make sure that selected only is either checked or unchecked based on your preferences. And now this file has been sent through our CNC software and we're ready to start making cuts. So on the table you can see the 2-inch rigid foam insulation. We've just completed the rough pass, and now we're completing the final pass. This phase, the final pass, is almost complete. You can see all of the detail that we've put into using the subregions and offsetting those in 3ds Max, and you can get a sense of what the final model looks like. Using some drywall compound and some water-based white paint to complete the model. So in this lesson, we were able to export Revit geometry to 3ds Max, establish a printable cuttable scale for the topography model, modify the subregions from Revit in 3ds Max to articulate features in the physical model, and export the 3ds Max file for the CNC router software.